Hello class. Today we will discuss about the third portion of classification that in the previous class we have studied about the lyophilic colloids and lyophobic colloids. In this separately we will study about the association of colloids. Association colloids, sorry, not association of, it's association colloids. Separately this I am doing because you may get separate question for 7 marks or either for 5 marks. Sometimes they will ask explain in detail about the association colloids, or sometimes they ask us explain in detail about the soluble micellerisation, micellerisation, or you can expect micellar solubilization. Explain in detail about the micellar solubilization. If they ask association colloids, micellar solubilization, micellerisation process, you have to write this answer itself. So first now we will see what is association colloids. As it is a self-explanatory term, association means individual we will form a group, we will associate together. Associate together means we are forming a group, a larger individual we will have, then we will come close together to form a association or a group. So association colloids. So who is the main hero of this association colloids means the monomer. This I can say this individually we will call it as a monomer, or here we are specifically this we are saying amphiphils. Amphiphils, individual monomer, or you can say surface active agent. All are one. Okay, surface active agent. So it have two parts. One is the head and other is the tail. The head is always polar in nature, whereas the hydrocarbon tail is always non-polar in nature. So this is about the amphiphils or the monomers individually. So what happens here, you see just first picture what I have explained. In this picture, first what happens, we have taken a glass or a beaker halfly filled with the water. So this is the water portion and this is the gas. Halfly filled means air will be present. So it forms the interface. It forms the interface of liquid and gas interface it will forms. So the positive what I have shown in the red color, these are the dispersed particle which is present, are the particles which is present. What I will do, I will take a solution of surface active agent, say for example sodium lauryl sulfate, that is SLS, as a surfactant I will take. So I will keep on adding that surfactant into the solution, into the bottle which has dispersed with the dispersion medium. So what will happen at the beginning, at the lower concentration level, at the beginning what will happen, it will form or it will get absorbed. We can say it will get absorbed. So here you can see the monomers, it will get absorbed to the particle which is present in the interface. It will get absorbed means absorption is the surface superficial phenomena. Later on, as the concentration of surface active agent I keep on increasing, it will form a concentrated layer. Here you can see this. It will form a concentrated layer. Concentrated layer or saturated layer of monomers along with the particles. This is the solution, or this is the concentration of surfactant or surface active agent which is equivalent to CMC, we can say, which is equivalent to CMC. Now the new word you have come across, CMC. So what is CMC? CMC is critical micellar concentration. Critical micellar concentration. You can get for 2 marks this question. What is critical micellar concentration? It is the concentration range of surfactant. It is a concentration range of surfactant at which micelle starts forming, at which micelle starts forming, is called as critical micellar concentration, and the unit by which we are representing it is by W by W or V by V or W by V. That is weight by volume, volume by volume, or weight by volume we are representing it. Okay. So then what is micelles? As individual monomer, I have told amphiphils, it doesn't comes under the colloidal size range. If you remember, the colloidal size range, it starts from 50 to 100 Armstrongs or 0.5 to 10 micrometer, I have told. So it doesn't comes under 50 Armstrongs. So as keep on increasing the concentration of surfactant, once it will form a saturated layer and it form association. Here in the second picture you can see this is the monomer which will get adsorbed at the interface, and later on it will form a association. It forms the association. That association which comes under or a group of monomers is called as association colloids, which falls in the colloidal size range, that is 50 Armstrongs. This falls in the colloidal size range, that is 50 Armstrongs, and this colloidal association of monomers are called as technically micelles. Technically what it is called as micelles, M-I-C-E-L-L-E, micelle. So then what is CMC, critical micellar concentration? The concentration range of surfactant at which micelles starts forming. So micelles can start or micelles can form of two types. One is the spherical type micelles and the second is the laminar type micelles. Here you can see this is spherical type micelles, we will say. Here this spherical type micelles, what happens, say for example you have taken hydrophobic drug, and I have told one more thing, that this may ask either association colloids or micellar solubilization also they will ask. How means, say for example I have taken phenobarbital. Phenobarbital is insoluble in water, that is it is hydrophobic in nature. So I had to increase the solubility of phenobarbital. So what I will do, I have prepared the colloidal dispersion of phenobarbital, that is phenobarbital along with the dispersion medium. So now I had to increase the solubility of phenobarbital, that is to prepare a colloidal dispersion. What I will do, I keep on adding the surface active agent. What will forms, the phenobarbital, which is a hydrophobic in nature, will present at the center, and the monomers which I am keep on adding in the form of surface active agent will form a spherical shape. The head will be outwards the pocket and the tail will be inwards, because phenobarbital is hydrophobic in nature. So the tail is also the tail of the amphiphil is also a hydrophobic in nature. So the tail will comes to the hydrophobic pocket, whereas the head will goes outwards, thereby by forming micelles it increases the solubility of poorly soluble drug by forming micelles. So this is about the spherical shape micelles, where it is forming a hydrophobic pocket and hydrophilic outerwards, which is of a spherical in shape. Same thing it will form in a laminar shape. Laminar shape, you can see the pictorially I have shown here, the concentration is equivalent to CMC. The concentration of surface active agent is equivalent to CMC, and the laminar micelles will form dynamic equilibrium with the monomers along with the micelles in bulk of solution. Here in this picture I have shown this. So this is about the monomers critical micellar concentration. One more theory here comes. The theory is called as Kraft point. You may separately get for 2 marks Kraft points. The Kraft points says the relationship between the solubility of surface active agent and the temperature of the system. the temperature of the system at which the micelles will, or the surface active agent will solubilize. So if I had to define what is Kraft point is defined as the temperature at which the solubility of surface active agent is equivalent to critical micellar concentration. Once again I repeat, Kraft point is defined as the temperature at which the solubility of surface active agent is equivalent to the critical micellar concentration. So this is about the Kraft points. And the here again we can tell the micellar solubilization if they will ask. This pictures, there it is 1, 2, 3, 4, 5. These 5 pictures you have to write if they ask about the association colloids. For 5 or 7 marks you can write. If they ask the same thing, association colloids, for 7 marks along with any other 3 marks question by asking explain in detail about micellar solubilization process, you have to add up this one more figure. Micellar solubilization is the process of solubilizing insoluble drug or dispersed particle by forming a colloidal dispersion by the addition of surface active agent at the concentration range of CMC, we can say. So here we have taken the examples of few: benzene, toluene, phenol, salicylic acid. What will happen like this type of drugs if it will take, how it will form the soluble micellerisation. We know that benzene and toluene are non-polar in nature. So they always present in a hydrophobic pocket. They always present within the hydrophobic pocket of the micellar solubilization. If we have the phenol, we know that the hydroxyl group constitutes for hydrophilicity, whereas the benzene group for lipophilicity. So the benzene structure will be present within the pocket, and the hydroxyl group which is attached to the benzene ring to form a phenol at the para position will be there at the interface between the pocket, hydrophobic pocket and hydrophilic dispersion medium. Thereby the same thing with the salicylic acid. The hydroxyl group and the acidic group, that is COOH group, also constitute for the hydrophilicity, and we know that very well the benzene group is for lipophilicity. So benzene will present at the center of hydrophobic pocket, whereas the hydroxyl and the carboxylic group will present outside the pocket, thereby increasing the solubility of poorly soluble drugs. So what are the application of association colloids? The application of association colloids is increase in the solubility of poorly soluble drugs. It can increases the solubility of poorly soluble drugs by micellar solubilization process. So this is about the association colloids, the third classification, where you have to remember amphiphils, the keyword you have to write, which is of a lesser than colloidal range, and you have to remember it forms surface active agents. Surface active agent at the concentration range of CMC, it will forms the micelles which will comes under the colloidal size range, that is 50 angstroms, and so it forms a association colloids. So it will form two types of association colloids. One will be the spherical in shape and the other will be the laminar in shape. Usually the spherical will present at the top or at the bulk, whereas the laminar type of micelles or Micllerisation process will form a dynamic equilibrium of micelles along with the dispersed particle in the bulk of the solution. And where comes the CMC as a definition? CMC is a critical micellar concentration, whereas Kraft point, it is the temperature at which the solubility of surface active agent is equivalent to the critical micellar concentration. And the application of association colloids is to increase the solubility of poorly soluble drugs by Micllerisation process is called as is the application of association colloids. Hope you understood. Thank you.